nth term of a geometric sequence formula. The nth term of a geometric sequence can be found using this formula. A sub n is equal to a sub 1 times r to the power of n minus 1, where a sub n is the nth term in a geometric sequence, a sub 1 is the first term, and r is the common ratio. So let's look at this practice problem. Find the nth term of the geometric sequence. And for this problem, we're trying to find the sixth term in this example here. So let's look at the example. A tennis ball is dropped from a height of 12 feet. Each time the ball bounces back to 80% of the height from which it fell. Draw a graph to represent the height of the ball after each bounce. All right. So first of all, if we're taking a look at this graphically, we have the height is our y-axis, and the number of bounces is our x-axis. Right. So at 0, the height is at 12 feet. And then at 1, 2, 3, 4, 5, 6, right? So at 1 bounce, the height will be 12 times 80%. So 12 times 0.8. That's 9.6. So hold on one second. That's 6. And then that's 3. 1, 2, 3. 1, 2, 3. 3. 1, 2, 3. 1, 2, 3. Okay. So at 1 bounce, the height is 9.6. So it's 10 is here, 9.6 is there. 9.6. Okay, at 2 bounces, we multiply that by 0.8 and we get 7.68. So at 2 bounces, it's 1, 2, 3, 5, 6, 7.8. So that's right around there. And then at 3 bounces, we multiply that by 0.8 and we get 6.14. So 1, 2, 3, 4, 5, 6.14, right about there. So at 3 bounces, the height is 6.144. But we don't want the 3rd bounce. We want the 6th term in the geometric sequence. So 4, 5, 6. So the 4th is going to be, and I'm doing this on my calculator here, is 4.91. So it's going to be 2 down. So it's going to be right here. My 5th bounce, it's going to be 3.9. So it's going to be right about there. And now my 6th bounce, I'm multiplying by 0.8 because it's 80% of the previous height, is going to be 3.14. So it's right here. 3.14. All right. And that's the one that we are interested in, the 6th term, which is 3.14, and we want to confirm it by using this formula. To use this formula, we need to identify a sub 1, which is equal to 12 times 0.8, 9.6. This is at 9.6. And then we also need our R, common ratio, and that is 80%, but in decimal form, so we're dividing by 100, and that equals to 0.8. And then we need our n, and our n is the term that we're looking for, so we're looking for the 6th term, n is 6. And we have everything we need. We have a1, we have r, and we have n. Okay. So let's plug everything in. So we have a sub n is equal to a sub 6, right? Where 6 is equal to n. We're looking for the 6th term. And that is equal to 9.6 a sub 1 times r, 0.8 to the power of 6, or n minus 1. All right, so let's go ahead and drop that all into a calculator. And let's say 9.6. No, let's start with 0.8. 0.8 to the 5th power times 9.6. and that is equal to 3.14. So we confirmed that this formula here does in fact work. Right? Let's go ahead and try it again for number 7. Write an equation for the nth term in the geometric sequence 96, 48, 24, and 12. And so in this case, our a sub 1 is equal to 96. Right? Our r is equal to, now we need to find the constant, the common ratio. So how do we do that? Well, we can go ahead and take the first term, multiply by r, and set it equal to the second term. But these are bigger numbers, so let's go ahead and try these two over here. They're easier, right? So to find r, we're going to do 24 times r is equal to 12. Right? So what is the number that we need to multiply 24 by to get 12? That is r. So then we'll divide by 24 on both sides, and we get r is equal to 1 over 2. All right, with the greatest common factor of 12, I divide 12 by 12, that's 1, and 24 by 12, that's 2. So I get 1 over 2 is my r. 1/2. And what is my n? Well, my n is my 10th term is what we're looking for. So now that I have my a sub 1, my r, and my n, I can plug everything into the formula. And we should be able to get this. A to the 10, or a to the n, a sub n, is equal to a sub 1, which is 96, times r. But r needs to be in decimal format. So 1/2 is going to be equal to 0.5, right? 1/2 is 0.5. And we have n minus 1. I'm sorry, n minus 1. So 10 minus 1, or to the 9th power. Right. All right, so let's go ahead and work this out. It's 0.5 to the 9th power. Okay, and then I'm going to take that and I'm going to multiply it by 96. And so the 10th term in this geometric sequence is 0.1875. And I'll box that. So my equation here is 0.1875, and my equation is a to the 10 is equal to 96, 0.5 to the 9th power.